physics around them, ignorant of the significance of the imposing principles that dictate their everyday lives, and
Scientifically, it describes the ratio of force and friction between bodies and force pressing them together, known as the normal force.
Those unaware of the physics around them, ignorant of the significance of the imposing principles that dictate our everyday lives, the wild dogs of our society will inevitably suffer in the darkness of the concrete jungle.
Today, we have come to see the effects of physics on driving. So, continue watching if you want to learn the physics behind driving.
Are you aware that your very existence may depend on the physics concept as simple as friction? This is where I pause for confounding astonishment to rack your minds. Yes, indeed. Every time you operate a motor vehicle in the rain, in the snow, in icy conditions, and even on clear sunny days, your safety depends on friction. Isn't it wondrously ironic that we know more about weapons customizations on Call of Duty or Modern Warfare than a simple concept that can save our lives? So please, for a moment set aside these thoughts of petty modes of popular entertainment while we explore the magnificent subject of the relationship between the coefficient of kinetic friction and motor vehicle safety.
Some of you uncorrupted by physics education may wonder, what is friction? I will answer it now. Friction is the force resisting the relative motion of solid surfaces, fluid layers, and material elements past each other due to intermolecular forces. To save ourselves from widespread condemnation for failing to use technical words, we will define friction as a force that stops objects from sliding. Basically, you slip on icy pavement because there is little friction between your boots and the pavement. This results in your precipitous descent towards the ground and mortifying shame when everyone stares at you. In contrast, it is hard to slide sandpaper past sandpaper. This task is difficult because there is significant friction.
I view the coefficient of static friction as playing a vital role in teenage lives. The coefficient of static friction, an intimidating term which has plagued physics students since its first use by Arthur Jules Morin in the mid-19th century, is merely a way of measuring friction. Scientifically, it describes the ratio of force and friction between bodies and force pressing them together, also known as the normal force. But what does this have to do with cars? The heavier the car, the more it will be able to press against another object, so the greater the normal force. The coefficients of static friction range from 0 to greater than 1. The coefficient of static friction to a car with air, as probably guessed, is quite close to 0.
At this point in our presentation, you are probably thinking about the best way to go to sleep without anyone noticing. We implore you to please show restraint. We understand that physics may be a bore, but understanding the concept, the coefficient of static friction, can save your life. The friction between the tires of your automobile and the road determine your maximum acceleration, and more importantly, your minimum stopping distance. Your stopping distance is the distance it takes for negative acceleration to change the velocity of your car, what it is when it's moving 0. So to all you butt sniffers, otherwise known as tailgaters, please remember to give other cars space, especially in the winter.
To all those teens out there who think it's cool to annihilate a deer with your car, it's not. There are consequences for both your safety and the deer's.
When you apply your brakes, the friction force of the road against the tires must do enough work to reduce the kinetic energy of the car to 0. That is, to make it stop. If the wheels of the car continue to turn while braking, static friction is slowing your car. When the wheels are locked, the braking force is provided by kinetic friction. On a dry road, the coefficient of kinetic friction and the coefficient of static friction is nearly the same, so it probably doesn't matter whether or not you apply your brakes calmly to lock the wheels. Now here's the scary part. In icy or rainy conditions, when the road is slick, the coefficient of static and kinetic friction are both lower than on dry roads, and the coefficient of kinetic friction is drastically less than the coefficient of static friction. This is why most modern vehicles have anti-lock brakes so that tires roll while braking.
So you think that because you have anti-lock brakes you can stop immediately in the icy conditions of tormenting Michigan winters? The answer is no. The coefficient of static friction for an icy road is drastically less than the coefficient of static friction on a dry road. Because on dry roads, most of the instantaneous contact is between the rubber tires and the cement road. And on icy roads, most of the instantaneous contact is between the rubber tires and the ice or liquid water. So what if the coefficient of static friction is less? With the same braking power, the force of friction slowing down the car is less, and negative acceleration is less. As a result, their stopping distance is much more in icy conditions.
By this time, you may be in a state of panic, wondering how you can change your driving behavior knowing that there is less static friction between your tires and the road on icy or wet days. The answer is pretty simple. Stopping distance is directly proportional to the square root of velocity to the vehicle and inversely proportional to the coefficient of static friction and acceleration due to gravity. Now what does that mean? Basically, the slower you go, the easier it is to stop. No one in this room has a good way of changing either the coefficient of static friction or the acceleration due to gravity. Those always stay the same. The only factor a driver such as you can change to decrease your stopping distance is your velocity. Yes, you need to decrease the speed of your vehicle on icy, rainy, drizzling, snowing, and hailing days. Start braking earlier because you know that it will take longer for the brakes to stop the car. This way, reckless hyenas, massive elephants, hippos, and gazelles will be able to experience safer driving conditions. Alright, well this presentation needs to leave you with some sort of meaningful message, so here goes. This is where we give you our message in magnificent jungle driving school words that will stick in your mind forever. Always leave one car space between the front of your car and the rear of the vehicle in front of you, and leave triple that space when there are adverse weather conditions. Look 5 to 8 seconds ahead, and look about 16 to 20 seconds ahead when there are adverse weather conditions. Always remember, when stuff falls from the sky, slow down, you won't die.
Thank you for watching, and remember, when the weather looks like this, drive like a cat. Goodbye.